Hi everyone, this is question number 21 in section 1.6. The question says, or what a question asks is, how much alcohol do we need to add to a 15% solution of 20 gallons to raise that solution to 25%? Well, the first thing we want to do is we're going to follow the outline in the textbook, and we're going to go with step one. And step one is going to be trying to find the quantities in this problem. And that's very important for this problem because a couple of the quantities are kind of hidden, and they're hidden in the percents. When we say something is 15% solution, we're saying that the quantity of alcohol, let's call this G of A, is gallons of alcohol, divided by the total volume of the solution, which is gallons of alcohol plus the gallons of water. This ratio is 0.15. Now what we're going to do in this problem is add more alcohol to this solution to bump up the percent solution, the 25%, or we're going to get a ratio of 0.25. Let's call that quantity capital G sub A. So this will be our additional alcohol. This will be our original alcohol. And this will be the water. The water is not going to change, but our alcohol, we're going to add more to it. It's very important with these percents to break them up into their ratios and to get the quantities that the percent is actually comparing. So for part two, we're going to try to come up with an equation that relates all of these together. Well, we have one equation right out the door, and that's the equation that describes where we get our 15% from. It's from the original amount of alcohol in our solution divided by the total volume of that solution, which is the gallons of alcohol plus the gallons of water. This ratio is 0.15. Now we also know something else. The solution, the original solution, has 20 gallons. So we know that G sub A plus G sub W is equal to 20. Now, when we compute our final number, we're going to want to, excuse me, we're going to include our alcohol. We're going to add it in, and it's also going to be added in to the total volume of the solution, because of course it's part of that total volume. That's going to come out to 0.25. Now, with these equations, we should be able to come up with a way of solving for G sub A. So between these three, we're going to be able to do it, and this is how. First of all, we can replace GA plus GW with 20. So we're left with an equation that has capital G sub A and little g sub A. If we can find a value for little g sub A, we can solve for the big G. Well, there is a way we can do that. Remember, since this is equal to 20, we can also replace this with 20. Well, solving for little g sub A isn't too bad. We just multiply both sides by 20. And that'll leave us with little g sub A. 0.15 of 20 is going to be equal to 30. So now that we have little g sub A, we can come back to here and we can replace it. And now we can actually solve our equation. So now that we have that, we can multiply both sides by g sub A plus 20. These will cancel out over here. We'll have G sub A plus 3 equals, we'll distribute that 0.25, you get 0.25 G sub A plus 4, plus 5. We'll subtract 3 from both sides. then g sub a is equal to 0.25 g sub a plus 2. We subtract this from this side, we get 0.75 g sub a, which is equal to 2. If we divide this into 2, we'll get g sub a is equal to 2 2/3. And that's going to be our answer. To check our answer, we can plug this back in to our original equation, or actually really our combined equation. G sub a plus little g sub a over big G sub a plus g sub a plus g sub w. We want to see if this does in fact equal 0.25. Well, we found out from before little g sub a is equal to 3. So we'll have 2 2/3 plus 3 divided by 2 2/3 plus, now g sub a and little g sub w, if you remember, that's the volume of our original solution. That's equal to 20. So this will give us 5 2/3 over 22 2/3. I'm running that on the calculator real quick. Let's see, 22 plus 2 divided by 3. And that'll give us 0.25, and our solution works.